Welcome back. We want to do the next program that we want to work with, which we have named comparison and logical operators, where we'll explain how these pretty much work. So building on the operators that we've done so far, so we've got comparison, and logical. So these, by the definition of the two terms, we'll then need to maybe see what each element does. We've got the less than, we've got the greater than, we've got the equal to, we've got the not equal to, we've got less than or equal to, greater than or equal to. I'm not sure if I'm naming these correctly, but these are the operators that we want to be working with. And then these will be our comparison operators. At the same time, we then now need to have our logical operators, which will be as follows. We then say, outside of these ones, we then need to have an and. We then need to have an or. We then need to have a not. So these usually come in pairs, simply because in part of our programming, we can have this bar representing something else. We can also have this and representing something else. As you can take note, when we were working with our scanf, we used to say, or we said scanf, we open and we close brackets. We then put our format specifier, which is %d. We put a comma, we put an ampersand, and we put the variable name. So in other words, this ampersand here represents something totally different to that particular ampersand. So we'll then be wanting to see how we can make do with what we've got and give an example of how each element works, or how we can actually put these operators into play. So the best way to do our code will be as follows. We'll need to first do the comparison, then we get into the logical. So I can split my code as follows. I put a comparison, operators, and would want to just give examples of how these can work. So as we have already started, we need to know that we need to have variables. So in this case, we can have int L val, and we can also have R val, which is short for left value and right value. Okay. We then also now need to be able to see how we can compare these values. So maybe we can have a simple value that will be able to define what each of these values mean, or we can use to get what each of these values can be. So we can call it as a result, maybe. We'll call it a result value, whereby we are then saying each time that we are getting our result, we want to use the equal sign, which we said helps us to initialize whatever value it is. So the result is what we want to give. So we then say result is equal to, that's the first bit, L val is R val as well, whereby we are saying we want to compare these two values and see what they give us. Although before we get to this stage, we need to initialize our L val to 8 and our R val to 12, like that, so that we can be able to compare these values. We can then have a printf that shows us what these values give us. Okay, so we want a definition of what this does. So operator, we put the operator equals, we put a percentage %d, because we can get an integer value from these two, where we put our results. I'll explain in a moment why we are doing it this way. So here's what we are saying. We're saying when we start our code, we've got the left value, we've got the right value, and we've got our result. Our left value is equal to 8, our right value is equal to 12. In the previous programs, we were trying to give the actual result of each of these values. But in this particular program, we want to see either a true or a false. So the integer value of our result should either give us either true or false. So true or false is between a 1 and a 0. I'm not sure which one is which. Let's just run it and see what it gives us, and then it'll be easier to explain from there. So we are saying for this operator, we are saying 8 is definitely less than 12. So it gives us a 1. So 1 should then stand for true. Let's do the opposite for the next value and see if it still gives us a 1 or it gives us a 0, because we're going to be changing the operator. Okay, we then put it like that, a simple copy paste. We change the operator and then we run it again. So after changing the operator, we can then now see that this is now a 0. So our 0 stands for false because our 8 is not greater than 12. Our 8, however, is less than 12, so that becomes true. So in other words, we're then saying all we are looking for is whether each element is true or false for each of the values that we would then be wanting to work with, or to see how each value can be represented. So this then gives us the answers that we'll be looking for based on our code. So all we are simply saying now is we've got our variables, but we're comparing what these variables give us, and then we can be able to see whether it's true or it's false until we have gone through all the comparison operators that we've got. So far in our comparison operators, we've got this one, and we've done it. Okay, so our equal sign, however, I'd actually put it this way. This is actually wrong because this gives us the assignment. But for us to then get a comparison, we need to add an extra equal sign so that we're actually comparing the two values. So in other words, you then find in some cases when you're getting an error where it says the left operand or the right operand does not match, it then means your operator is most probably wrong. So you need to then figure out how you put your operator, and also if you've got your assignment and your comparison, you might face a challenge. Let's just try and do the equal sign in the next stage so that we see if it will work in such a scenario. Okay, let's stop our program. We run it again. Okay, so it does work. It gives us a result. So in this particular case, we're saying these elements are actually not equal. So this is then false. Okay, so that then means we are on the same page. But I think since we are working with an equal sign, let's put our equals in brackets, so that at least when we run it, we can see that the operator that we're working with is equal, and then we get the value that it gives us after we have run it. Okay, so the next operators will be pasting in the same manner, and we'll just be changing and seeing what each value gives us. So for this one, we said it will be or equal to, and then we put an equal to sign there, and then the next one should be the opposite of this one, whereby we are saying is greater than or equal to, and then we also change the sign there where we say greater than or equal to, and then we can be able to see what this gives us. Okay, so we are saying this particular result, which is on line 16, is true because it is the same as that one, but we're just added the extra advantage to say maybe it's equal to. And then the next one, which is this one, is false because it's not greater than the value that we're looking for. Okay, we've got one more operator that we need to work with, which is this one. We then say is not equal to. So we put an exclamation mark and an equal sign. Okay, let's just run it. Fine. So the not equal to is true. So in essence, let's just run through this again. We are saying our operators work in this way. The first one is the less than. So we're saying in our less than, we go to line 9. We're saying result equals to L value is less than R value, which is true. So when we come to our console application, we'll actually then note that 1 represents a true value. The next one, we're then saying in line 11, we've got L value is greater than right value, which is false. So the answer that we get on our console becomes a 0. The next element is our equal to, which is on line 13. Line 13 then gives us false because we're saying the two values are not equal. We then move on to line 15, and line 15 is saying L value is less than or equal to right value, which is true because it is less than, but it's not equal to that particular element that we are working with. The next line that we look at is line 17, where we are saying it's greater than or equal to right value, which is false because it's not greater than. And then the last line gives us is not equal to. Okay, so not equal to gives us a true because we know that the left value and the right value are not equal, and this gives us a true aspect. Although this applies to every other element that we are working with, whereby if you are working with programming, you may need to compare values that you may not know of or that you want the user to enter whilst they are running the program. So as they're entering the values that you're looking for, your program should be able to match the values that are on the left and on the right side, And this is how we work with our comparison operators. So these are our comparison operators. We'll actually get to look at these more in our control statements and in the next session that we want to be working with, which is our logical operators. So our logical operators will also build from our comparison operators, in that we'll also be able to check the specifics of any of the values that we might want to work with or we might want to use. Okay, so this then becomes our comparison operators. Let's maybe make it look a bit more nice. Here I'll just add another new line. Here I'll add a tab control, which is \t, so that we add some space to it. I'd also not explained our new line and our \t. So what this simply means is, with our \t, it puts a tab space on our console, and then our \n puts a new line on our console. Okay, let's just run it and see. So after having this done now, we've added an extra space between comparison operator and the operators. We've also added some space between the edge of our console to where each line is now starting. So it now looks a little bit better on each aspect. We can move on to the logical operators, and then this lesson is complete. Okay, so let's do the same. At this particular point, I'll just like to put a printf that gives us new lines. Okay, then the next thing I want to do is a printf that gives us the logical operators. Okay, so we still want to work with the same values that we've got, and we then want to see what each element does. So in essence, we're still going to use these logical operators as they are, and we can do the same thing and say results equals l_val and r_var, like that. Okay, but this now gives us a little bit of a challenge, in that we are saying our result, we want to get the value of this variable and the value of that variable, but we are not stating why we are putting them in this way. So we want to be able to check for specifics, because as it stands, if we put a printf, we'll be able to get a result, but the result may or may not make sense. So let's say we put our two ampersand signs, and we put an equal sign, we put our %d, we put our new line, we put our results. Let's run it and see. Okay, we are saying our result is equal to left and right value, which is 8 and 12, which is okay, but we have really not put any logic to it. So in essence, it gives us a value, but it has not done what it's supposed to do. So we are then saying, in a sense, We then now need to put some comparison to it to say, what are we doing with the value, with the first value? What are we doing with the second value? So in other words, for this to sort of give us something that we can work with, we can then maybe say the following: result is equal to L value is less than right value, or L value is not equal to right value, like that. So in other words, we're then saying we want to check, is this statement true, or is that statement true? Okay. If we then put our printf, we can then be able to do the following, to say our result, in this case, I just found too many arguments there. And then we put our result like that. We can be able to then run it and see what this gives us. So I put too many arguments there, but I'll explain how it works. We are saying in the first line, which was line 23, result is equal to left value and right value. Okay, so in other words, logically it makes sense. We are saying our result just gets to check if we've got a value for the first element and we've got a value for the second element, and that is true. But that, though logical, does not make sense. We need to be able to compare the two values. The second line, however, which is line 25, we're saying our left value and our right value. We are saying the left value is less than the right value, which is true, or we are saying the left value is not equal to the right value, which is also true. So in other words, in this particular case, we might have a scenario whereby we want to check between two instances. One instance is, do we have a value? If the answer is true, then we need to go to the next question, whereby we'll be saying, if we have a value, we need to proceed to go to the next question. However, if there is no value, it then means that question remains unanswered and you need to answer it. So in other words, when you're creating a system that is time bound, or a system that requires the user to input something, we'll then be able to check whether the contents that are there and the contents that are required are matching, and if they are matching, we can be able to go to the next stage. However, we always need to then logically put our content within the context of what we are hoping to do. So in this case, we have used the OR operator. Okay, in this particular case, we have used the AND operator. Okay, at the same time, we can also then maybe reuse the AND operator, and I'd actually forgotten that in this particular part as well, we've also included the NOT operator. Okay, so we can redo our AND in this particular case. We can say result is equal to L value being greater than right value, and right value being less than our value, like that. Okay, so in other words, we've worked with our AND again, and we should be able to get a result. Okay, so let's copy this, let's paste it as result, because we'll still get exactly the same thing that we had before, but we want to see what this logic gives us. Okay, so we are saying in this particular case now, because we've put the comparison operator, line 27 becomes different from line 23 in that the result is different. We are saying, is our left value greater than our right value? Which is no. Is our right value less than our left value? Which is also no. Right? And we're comparing these two side by side. We'll then get to realize this is not true, so we get a 0, which stands for not true. And at the same time now, we can then be able to say, when we are moving on from operators to go to our control statements, we can now be able to see how we can control the output of a given program at any given time, and with the given content based on how our program or our logic is spaced or given to the functioning of the program, or to correcting a specific element in a given program. Okay, so here ends our next lesson.